So we're discussing thermodynamics, and in thermodynamics we are discussing degree of freedom, values of Cp, Cv and all. Write down the question. 10 moles of hydrogen gas are heated at constant volume such that temperature increases from 20 degrees Celsius to 25 degrees Celsius. 10 moles of hydrogen gas are heated at constant volume such that temperature changes from 20 to 25 Celsius. Find out heat supplied in the process. How much heat you should supply to the hydrogen gas? 10 moles, so that you can change the temperature from 20 to 25 degrees. Answer the question. Look, delta Q, delta U plus delta W. Delta U and CV, delta T, delta W is 0. Constant volume, no work. N 10. CV it's a diatomic gas. What is CV for a diatomic gas? 5R by 2. Delta T, there is no need to convert 20 and 25 into Kelvin because difference wise Celsius and Kelvin are same. 25 minus 20. Answer 5, 5, 5. 125 R. That's the answer. Good. Let's see how much you understand this question. Solve the same thing, but this time process is repeated at constant volume, constant pressure. The question is, solve it fast. There is no need to repeat the question again and again. Same thing is being done, but instead of constant volume, we have constant pressure. And those who want to write the question, they can write it also. At constant pressure, 10 moles of hydrogen gas are heated from 20 to 25. How much heat is supplied? Answer the question fast. Should not take more than 15 seconds. Look, two things. At constant pressure, delta Q, delta U, delta W. देखना, बाद में नोट करना. Delta U is always NCV delta T. delta W for constant pressure is nR delta T. For any type of process, you always use the same thing. So what is delta U NCV delta T? It is at constant pressure, but doesn't matter. Delta U is always NCV delta T. Work done in an adiabatic process is what? nR delta T. But this is correct, but do not prefer this method. The moment they say constant pressure, use Cp. What is Cp? Cp is dq upon ndt. Any molar specific heat capacity is what? dq upon ndt. The process is what? At constant pressure, they are looking for dq. What is dq? N Cp dt. What is N? What is N? 10. What is Cp? For hydrogen, Cp is what? This is 5, a jump of 2, 7. R by 2, dt same 5. This is coming what? 2, 5, 5, 5, 25, 25, 7 are 175 R. If you use this, again you will get what? 175 R. But prefer this. What about this? Could we have done the same thing here? Yes. लेकिन उससे असर नहीं पड़ता क्यों? Because delta W is already what? 0. If somebody wants to use the same technique here, कोई issue नहीं है, करो. You can write dq upon ndt as Cv. Same cheese. Now answer the third question. If the same thing is done adiabatically, you are increasing the temperature from 20 to 25 of 10 moles of hydrogen adiabatically, then how much heat will be supplied? Answer this in 10 seconds. Bahut sahi, good. That's what is expected. It should be this quick. Now once I say adiabatically, log C for adiabatic की तलाश में निकल जाते हैं. What is adiabatic? Basically, I'm telling you that do not supply any heat. That is what? Adiabatic process. Do not supply any heat. Change the temperature from 20 to 25. How much heat are you supplying? अरे बोला ना कि do not supply any heat. And therefore, what is the answer? 0. So who will tell me how much heat will be supplied if the process is an isothermal one? Who is going to answer? How much heat will be supplied if the process is an isothermal one? What will be the answer? Fast. People are still saying 0. No. The first answer is correct. How can it be possible that you are changing the temperature from 20 to 25 and also saying that process is isothermal? The answer is it's not possible. You cannot say that temperature is kept constant, heat is supplied and temperature increases from 20 to 25. पहले decide करो ना कि temperature बढ़ रहा है कि नहीं बढ़ रहा है. And therefore, if the whole thing is an isothermal one, then it's not possible. Well, I hope everybody is comfortable with the previous part. When I said isothermal, I'm still getting answers like 0, infinite or things like that. No. Isothermally, once I say temperature should be kept constant and then increase it from 20 to 25, question is not defined. You will not say infinite, question is not defined. Now, look at this. Inside a cylinder we have helium, and this is the piston, and it's a massless piston. Heat is supplied, temperature increases. Outside pressure is P0, atmospheric pressure. Heat is supplied, which we have to calculate. Temperature increases such that delta T is 4. Find out delta Q. Everything is in this. What is the question? Inside a container, a cylinder, helium gas is present, N moles, covered by a massless piston. The piston can move up and down. It's a massless piston. Mechanics. How much heat should be supplied to N moles so that temperature increases by 4 Kelvin? Let's see who can answer this. छोटी सी काम की चीज सोचनी है, and the question is done. I'll ask the question in this form. It's a massless piston. What type of process do you see? Isothermal, isobaric, isochoric, adiabatic. Think about this. Once I say it's a massless piston, what type of process it is? If you can think about this, if you can answer this, you can answer the question. बहुत सही. It's an isobaric process. Those who could not think that it's an isobaric, take 10 seconds, think about it. How come it's an isobaric process? Let me answer the question first and then I'll explain how come it's an isobaric one. If it is an isobaric, that's how your dq will appear. NCPDT. Number of moles N. Cp. Helium. Monatomic gas. For monatomic gas, Cv is 3, Cp is 5. 5 R by 2. Delta T is already given as 4. N. Cp delta T. The answer is 10 R. And some of you even got 10 R, which is a good thing. Now let me tell you how come the process is an isobaric one. I told you mechanics. What is mechanics? Free body diagram. Let's draw a free body diagram. What is the force coming from this side? P0 into A. Pressure multiplied by area. देखते हैं ना. Downward force mg, and the force which is coming from the inside, is what? P multiplied by A. What is P? Pressure of the gas which is inside. What is P0? Atmospheric pressure. Mg, the weight, and piston is going up with an acceleration of A. Capital A is the area, small a is the acceleration. So how do you write equation? F equals to ma. What is that? Pa minus P0 A minus mg equals to ma. Pa minus P naught A minus mg is Ma. But what is the mass of the piston? 0, massless. 0, 0. It gives you P as what? P naught. That means what? Whatever be the volume, since it's a massless piston, pressure inside is always what? P naught. So a gas under a massless piston like this is nothing but an isobaric system. And for isobaric, this is the answer. If you understand this, then write down yes in the comment box and then you can leave. Thank you very much.